The world's fastest fiber placement technology. It's completely unique. It's a totally new production process. We shoot commingled yarns inside precisely machined channels by making use of an airstream. All of this happens in just milliseconds. We bring the advantages of additive manufacturing to mass production.
I must say, I wasn't expecting this. Someone comes to you and say, hey, could you make us a prototype? How fast can you do that?
We can do this within a few weeks. The quickest prototype we produced over a weekend.
Wow. So what you're telling me is you're planning to take over?
Yeah.
Normally what I do is when I create a video, I do a bit of research behind kind of like what do they do. But I was recommended for what you're doing not to research it so I can discover it. So I'm actually quite excited. Tell us a little bit about yourselves.
Yeah, perfectly. So I'm Elias. I'm one out of three co-founders of Fibionic. Lightweight design is a powerful enabler across multiple industries. But when it comes to composite structures in high numbers, they are still rarely found because manufacturing is either too cost intense, too slow, or too wasteful. That's exactly where Fibionic comes into the game, because we follow the mission to make lightweighting affordable and especially also sustainable for the mass market.
Lightweight, affordable, and sustainable.
Exactly.
Brilliant. That's a big challenge.
Yeah, that's a big challenge. But we do so by following the principle of nature, because nature shows us already how to perfectly set up structures. And we combine this bionic design principle with the world's fastest fiber placement technology. So everything starts that we align each fiber according to the load path by using our molds we have created. Basically, we close the mold and then we shoot commingled yarns, endless fibers, inside precisely machined channels by making use of an airstream. All of this happens in just milliseconds.
Okay, so you're shooting commingled fibers into channels into a mold tool?
Exactly. So if we have a look at this form, for instance, this is the case. So here we have the example of a bicycle saddle. In this case, we shoot in each of these kind of channels a commingled yarn.
Wow.
By applying an airstream. And then in the next step, we can stack up multiple layers. We can also cross-align layers. We apply also heat to the stacked layers, so the thermoplastic material melts and the shape is secured. So the form of the positioned layers do not move anymore.
So your preforming process here, single layer, seconds, really fast. And when you stack it up into a more complex geometry, and that too can be automated quite easily and can be quite fast, right?
Exactly, it's fully automated. And in the next step, we take the stacked fiber layers and consolidate them. So we receive something like this. It's a two-dimensional shaped structure, in this case of a bicycle saddle.
You have multiple layers which has been stacked on it.
Exactly.
And you turn it into a flat sheet. And because it's a flat sheet, you can do that really quick. But I suppose when you put it on the mold tool, are you heating it and cooling it, or just do hot press?
We heating and cooling, exactly. That's what we are applying. In this case, we have 11 layers. We have 8 layers for the main loads, 3 layers for the side loads. And in the final step, we basically do some classic thermoforming by pulling back home. And what we receive is the 3-dimensional shaped fiber skeleton structure. The reason why we do the consolidation process in a 2-dimensional is that until here the process is totally repeatable. So no matter what kind of part we are making, we just have to put in such a tool inside the fiber inject process, and then we can start to produce fully automized until here. So we save a lot of costs because we don't have any tooling costs for the consolidation process. This kind of shapes do perfectly fit for injection molding, for instance. So you can integrate this load-carrying structure inside, in this case, a bicycle cell inside injection molding.
Wow, that is a beautiful geometry. And so in this case, then you have standard polymers in there, maybe some fiber fill, and then you got oriented fibers for that extra directional.
Exactly. And
wow.
The very nice thing about this is we are using here a commingled yarn. In this case, it consists out of 3K carbon fibers and a thermoplastic material.
Okay.
You have PA12 in this case.
Yeah.
And the injection molded material is also PA12. So we can make sure we have a perfect bonding. Yeah.
I must say, I wasn't expecting this, right? Like I told you, I didn't research this at all on purpose. This idea, does it exist in a different industry?
It's completely unique. It's a totally new production process. And what I have to mention here, we can assure cycle times of 1 minute per finished component. And that can be the real game changer in terms of bringing composites, so shallow-shaped composites, to the real mass. So we bring the advantages of additive manufacturing to mass production.
Absolutely. I mean, normally if you showed me about geometry, the first thing in my head is this is TFP, but the deposition rate for TFP is, I don't know, maybe you have 5 or 6 heads. It's still very slow. In your case, you're doing it in fractions of a second.
Exactly.
Spinning it.
So it's really a new technology. We call it FFP. It stands for Fibionic Fiber Placement. I think that's everything from my side, and I hand over to Johannes.
So until now, we've focused mainly on the sports and leisure industry. It's our beachhead market. Our early adopters market, we can find them there. But from there on, now we're really spreading across industries.
Okay.
So we have a first project in the drone sector, optimizing weight and performance for drone propellers, for example.
Okay, yeah.
And there our customers see the huge potential in scaling up production. And also there's a very interesting development going on in the sector of humanoid robotics. And talking about humanoid robotics, and we are producing fiber skeletons, it's a perfect match. So we can implement fiber skeleton in human robotic parts to make them lighter and more efficient in the future. We want to further expand into markets like automotive, aerospace. So actually, there's almost no limit. We can go in any direction.
With your tooling and all of that, what's the speed of turnaround? So someone comes to you and say, hey, could you make us a prototype to show something? How fast can you do that?
We can do this within few weeks. So it always depends on the capacity we have. The quickest prototype we produced over a weekend.
Wow, that's amazing.
So we are now offering prototyping and development services.
Okay.
We're also offering the opportunity for large volume in-house production at Fibionic. But we're not going to stop there. In around 1.5 years, we are going to offer the whole ecosystem to the market.
Okay.
We're going to sell our software as well as our prototyping equipment, but also the series production line with the right material. So because we think we can set a new industry standard for shell-shaped parts, and it's impossible as a small company to do this. So we really want to provide the industry with our production technology to make Fibionic as big as we see.
So what you're telling me is you're planning to take over?
Almost.
That is absolutely brilliant. Thank you so much. I am delighted, and I wasn't expecting to see what I saw today, and this is truly, truly amazing.
Thank you so much for your time and your interest.
Thank you very much.